Hello everybody, how you doing? I figured I'd give it a shot with this video stuff, so I'm going to go ahead and do a few videos to show how to do some problems. People have been asking me about problems. Stuff that you can define. I guess you can, for the most part, get it, although I will be talking about a few definitions right now. But then we'll do some sample problems. So right here I want to get started, and you'll excuse our crude, primitive equipment that we've got going on right now, but we're kind of working this out. What I have here is a couple of substances, chemical substances. I got water, a compound, H2O, and I got sodium chloride, also known as salt. Right? And both of these are individual chemical compounds. They're pure substances. And watch what happens now. I just made a solution. Let's remember that a solution is an example of a mixture. And if I go ahead and dissolve this in there, and you guys know this will dissolve, this turns into what we call a solution. Solutions when you got two substances mixed with each other. Now, I put the salt in the water, making the salt be the solute. You should know what the word solute means. It's the substance that gets dissolved in something else. Okay? A solution is both a solute and a solvent. The water is the solvent. It's kind of what's doing the dissolving. Right? And so salt in the water, then the salt is your solute, and the water is the solvent. Okay? Now these are relative terms, because usually the solvent is what's around in much larger quantity, and the solute is what's in the smaller quantity. So usually the smaller thing gets dissolved into the bigger thing, because the bigger thing kind of overwhelms the smaller thing. Right? But they're relative terms. If I put 50% alcohol, 50% water together, which is the solute, which is the solvent? Really, it's kind of hard to tell. And in the end, who cares? It's a mixture of 50-50 alcohol and water. But when it's obvious that there's one thing that's dissolving something else, we say the thing that's doing the dissolving is a solvent, and we say that the thing that got dissolved is the solute. And this one still hasn't dissolved completely. There's still a little bit at the bottom, but if we go ahead a little bit, make a little less noise than the first time, that eventually it'll all dissolve. Okay. Now a couple of other terms. There are dilute solutions and concentrated solutions. So you'll notice that I went ahead and I made a solution right here by mixing two. What if I get more salt? Put some more in. Make that. That's still a salt water solution. They're both salt water solutions. What if I get more salt? And more in there. I keep dissolving more and more until no more will dissolve. They're still salt water solutions, but they're not the same, right? When I only had one spoonful in, it had a certain amount of salt. And the more I kept putting, the more spoonfuls I kept putting in, the more salt was in there. This looks a little cloudy right now, but it will clear up. Eventually, it'll all dissolve. Sometimes it takes a little while for it to dissolve. The more solute I put in there, the more concentrated our solution is. So we say it's a concentrated solution. The first one only had a little bit of solute in there, and so we call that a dilute solution. So another difference between a concentrated solution and a dilute solution. Okay, and when we can't fit any more in, when we've reached a solute's solubility, right, which is the maximum amount you can put in there, we've got a saturated solution. So a saturated solution comes to the point where you can't dissolve anything in there anymore. On the other hand, as long as I can continue dissolving more, it's called an unsaturated solution. So those are a few things to kind of, note, some definitions that you should be able to know what they are. Okay, I just thought I'd give you guys an example of what that is. The rest of the video is going to show how we can calculate these concentrations, because we want to be able to describe them. I mean, was it kind of a dilute solution? Was there concentrated? Was it kind of concentrated? Was it very concentrated? I mean, we just don't want to know that. We want to know more specific, how concentrated it is. So what we do is we have different ways of measuring concentrations. There are 5 different ways. We're going to talk about one of them today, and I'm going to let you guys read on the others. So percent by mass. This, by the way, is a table in your book. It's in chapter 15, section 1. I forgot to look up what page it's on. But this tells you the 5 different ways that we have of measuring concentration. There's percent by mass, percent by volume, molarity, which is what we're going to be doing sample problems of in a little bit, molality, and mole fraction. This one we'll deal with later on. Okay. Percent by mass is just taking the mass of your solute divided by the mass of the whole solution. So if I were to figure out how many grams of salt I put in here, and dividing it by how much the total mass is, that would be my percent by mass of my solute. Percent by volume usually works with liquid solutions. That's when you would go ahead and take the volume of the solute divided by the volume of your whole solution. You get 100 milliliters of alcohol and 400 milliliters of water. That's a total of 500 milliliters, right? Well, of those 500 milliliters, 100 milliliters was alcohol. So you take the 100 milliliters of alcohol divided by the 500 milliliters of the total solution, and that's going to give you your percent by volume. And these 2 things are kind of nice and quick and used a lot, for some basic stuff. But the one that we use a lot in chemistry is molarity, because you guys know we use moles a lot. And you can see the term right here, molarity, has the word mole in it, so we can know how many moles. These guys kind of tell us what percent of solute versus solution. This one tells us moles. Okay, and so in the rest of this video, we're going to use this equation right here to calculate what's called the molarity. The molarity of a solution is how many moles there are of your solute for every liter of solution. Okay, our units are molar, like a molar tooth. So what molarity tells you is how many moles of solute there are for every liter of solution. So if you had 1 liter, how many moles would be in there? Now, a lot of times you won't have a whole liter. You'll have less. But what molarity is telling you is that this is the same concentration as if you had a liter, how many moles would be in there. So the amount of space between the solute particles is going to be the same, even if you blew it up to a liter or brought it down to a liter. Okay. We're going to have this formula. Capital M stands for molarity. Is going to be equal to N, which stands for moles of solute, divided by V, the volume. And see that parentheses L? That's not another variable in the equation. That's just to remind you that the volume has to be in liters. So really it's just 3 letters. Molarity, capital M for molarity, N for moles, and V for volume. Okay. And we can do some calculations with that. Let's do some sample problems.